So very good morning to everyone. So I welcome you all to this international webinar on XGBoost Regression for Civil Engineering Applications from Data to Decision Making. So it is my great pleasure to introduce our distinguished speaker, Dr. Daniel Cruz. He is currently serving as a senior lecturer in the School of Civil Engineering at University Saints, Malaysia, a globally recognized QS ranking university. His research expertise includes smart materials, structural dynamics, vibration control, energy harvesting systems, supplemental damping device, and hybrid simulation methods. Dr. Daniel has authored and co-authored more than 54 indexed research publications, secured several research grants, and successfully completed industrial consultancy projects. He is an active member of prestigious professional bodies such as American Society of Civil Engineers, ASTM International, Institution of Structural Engineers, Institution of Engineers India, International Association of Engineers. He also serves as a peer reviewer for more than 12 reputed international journals. So I once again extend my warm welcome to Daniel sir, and thank him for joining us today for sharing his valuable knowledge and experience. Over to you, sir. Thank you, sir.
Okay. Thank you, sir. So, can I know that currently students were seated in the computer lab? Am I right?
Yes, sir. Yes, sir.
So, you have shared the link, the Google Colab link.
Yes, sir. I've shared.
So
They have opened it, sir.
Okay,
Yes, sir.
it is right. Okay. So, can you know my voice is audible to all the students there?
Yes, sir.
Okay, fine. Okay, sir. So, I'm just sharing my presentations. So, good morning, students, faculties from SPCE. I'd like to thank once again the Professor Kumada, head of the department, for giving me this opportunity. And I'd like to thank Professor Vijay for coordinating this event. And I'd like to welcome once again all the students. Hope you all be in your lab listening to this. And you have to do hands-on, right? Hope you are having a system and don't do other activities parallelly. Maybe because these are all the recent trends. We work with related disciplines with other researchers. Like maybe a little bit it looks like codings and all, but it is very simple and easy. Even some coding contents, if you not understand also, you need to understand the results, applications finally. Okay, how we are applying for civil engineering related research. So I'm Daniel, currently in USM Malaysia. So today we are going to discuss about this topic on machine learning in civil engineering, predictive modeling with XGBoost regressions. Okay. So this term XGBoost regression is a machine learning model. There are so many machine learning models, around 1,000 plus machine learning models. For every data, the prediction of model will be different. For simple example, I'll tell you, this is the workflow. Okay, like step 1 to step 13, we are going to practice it hands-on in the Google Colab tool. Okay, one by one. You need to understand, hope you have given a Word file with code. Okay, it has the code. And you have been given another file, data, right? Data file with an Excel file. So hope you have three content. One is the Google Colab link. Next is the data CSV file. And third is the code file, the word file. Okay. So before going to those content, you need to know in the Excel sheets, not Excel, it's a CSV file, right? Data file. What result is over there? First thing is, this is a simple study which done hopefully I think some 2 years back in our lab in India where I worked earlier in Chennai. So one of my bachelor students, he took a seashell. He is from Kanyakumari down south. So he find these kind of seashells were taken, and some of them were kept as a waste inside of seashore. Okay, so he want to take that as a like it's a waste element. He want to use that for a paver block. So he prepared a paver block mold and he casted somewhere around I think 50 plus some number of samples. and he casted and he did the compressive strength, and finally you can see after the specimen testing how because the bonding is fine because the surface is not that polished or something. It's a good frictional surface. And with this data, then the predictive, the sharp as well as feature importance you'll be learning in the upcoming things. Okay. So I think till now, initially you have a seashell and using that you are mixing it and you are creating a pair block, and later on you are doing a compressive strength test. Finally, a specimen. Okay. The first thing is you need to import library. There are 13 steps. We will see one by one. Okay, 13 steps. So hope my screen is visible to you. So whatever I'm doing, just observe and try to do it. Okay. First, we have this data file, right? Just open this data file and check the data first. So this is a simple data. So the data can be created in two aspects related to construction material based research. So here these mix ratios were given in percentage. Some articles, this will be not in percentage, it will be in kg per meter cube. Some researchers, fly ash, if kg per meter cube means here you will get a different value. Cement also, M sand also, seashell also. But here I have given in percentage. So in total, somewhere around 50, yeah, total 50 sample is there. So for this, every 50 samples, you have the different compressive strength. Okay. So fly ash 20 percentage, 10, 20, 50. So different ratio. There are around 50 ratio. In each ratio, three specimens were casted, and the average compressive strength were kept in the F column. Okay, the average compressive strength. Okay, so you have fly ash, cement, and M sand, C cell. Okay, now you need to understand this data clearly. Okay, total around 50 datas, and these five datas like fly ash, cement, M sand, and C cell we normally call as a input variables. Okay, or input, and this compressed strength is the output, or also you can call as the target. Okay, see, some terms may be in the other discipline based researchers how they call, but this is an input variable, this is the output variable. Okay, in a simplified manner. Okay, now you have the code. I think this word file you have with you, the word file, right? So before going to this first step, I just go to the link where we are going to practice now. So first click file. I just go very slow. Professor, in case you want me to go a little bit slow, need some time, please let me know because I'm not able to see the process. So first click new notebook in Drive. So everyone click this collab research.google.com link and click file new notebook in Drive. Maybe here you can keep some name. Seashell training, some name you can. So can you know till this everyone completed? I think Professor Vijay, can you respond to me then and there where when the students are completed, you can say they are completed. Is it possible?
Yes, sir. Yes, sir.
Okay, okay. So can you know till this everyone completed? Maybe after completion of them, please let me know, Professor. So see those who I'll just repeat once again. Just click file and click new notebook in Drive. Okay. So it just take you here.
So they
So
have
once
completed.
they have completed browser.
Yes, sir. Yes, sir.
Okay, okay. Now after this, we need to go to this Word file. Just copy this. The step one. Okay, till this print. Just copy this and just paste it. After pasting, here you have an option, right? A play symbol, run cell. Just click. After pasting this, just click this play symbol. In 10 seconds approx, you will find a tick over here. You will find a tick over here. Now I'm going to see, just you need to copy the step one and just paste here. Now I'm going to slightly explain these details. First step is importing libraries. See, for example, if you are planning to draw a drafting in AutoCAD or any other tools, inside you will have a lot of library like hatch command, lot of input, lot of libraries will be available to do a certain task. Otherwise, it will be you will be not able to draw a sketch properly, right? Similarly, for doing this machine learning task, certain tools are to be imported to this Google Colab tool. This NumPy for mathematical calculations, Pandas for data tables, Excel sheets to read and do those works. XGBoost is the machine learning model. Normally, with the same data, I have tried with 25, 30 plus machine learning models, and I found this XGBoost is the best, and that best results only now I am presenting. Okay, but when you do your research work in future, you will be doing a lot of trial and error with multiple machine learning models. But now I'm just sharing you only the XGBoost model. Okay, there are AdaBoost, CatBoost, linear regressions, so many machine learning models, 1,000+ models are there. But a simple clue which I can give is what I used to do is I go to some websites like Google Scholar, some research article finding source. Okay, Google Scholar or mainly Scopus, Science Direct, certain websites. You just put a keyword like compressive strength, comma machine learning, or compressive strength, comma prediction, compressive strength, comma uh, like not optimization, like mostly machine learning related keywords. If you are providing, you will find lot of research articles. In these articles, they could have used lot of machine learning models. If you scrap that, you will find something around 15 to 20 machine learning models. So if you just try those 15, 20 models, obviously any three models will be closely related, like the best. Okay, that is a very simple one, but the best one only which I am going to present today. Okay, I done multiple trials and I find XGBoost is the best, so that alone only I am going to do it today. So this sklearn is something like splitting metrics validation of this tool. Then matplot is for plotting the graphs, and shop is something at last, the last step, which parameters is influencing most for this compressive strength study. So these are all importing libraries we have to do. So this is the code. Hopefully everyone you have copied and pasted. So have you get this tick symbol in the left end here? Maybe 10 to within, obviously maximum within 10 seconds. Maybe you could have get this, you could have imported. So here you can find finally all libraries imported successfully. So everyone got this tick symbol as of now.
Yes, sir.
So to add a new code box here, maybe when you bring your mouse over here, you can find plus code. Okay, this is also one option. You can click one time, just one time, or here you can find plus insert code. Just click. Also, you can get another code line. If you want to delete, you can just click delete here, and you can delete. Okay. So as of now, I just click this code here. So the code row is being created. So just create one. Maybe you can click here, or when you just come to the center here, you can find this plus code symbol. So hopefully, I think you could have all have this row now. Now go to the Word file. What is the step 2? We need to upload and load the data, right? So just copy this. Just play. Now you need to do one task after when it is running. There is an option called choose file, right? Choose file. Click choose file. It takes to the folder where your data is available. So I'm just going to the folder. So this is the file. I just click. When I click the data, immediately you can find the data, 50 rows. Total, how many columns? 6 columns were added. So after completing this, you can find here another tick is there. So here the the CSV file is getting readed and the data being loaded successfully to this Google Colab. So the second step is obviously we have to upload and load the data. So we know total 50 rows and around 6 columns. The first one is the mix name. S1, S2 is sample 1, sample 2, sample 3. And then fly ash, cement, M sand, seashell. These are all in percentage. Some researchers, they don't do in percentage. They add after mix design, they finally calculate the how much quantity, kg per meter cube, how much kg per meter cube of fly ash were used for a single samples. And similarly for cement and M sand and seashell. So here you need to understand one thing very clearly, as I said earlier, the 4 elements, the fly ash, cement, M sand and seashell. These 4 are input and final one is compression. Some researchers, this is a very simple tutorial I'm just making here. Some researchers, they add other elements to, for example, how much water, then water cement ratios. So a lot of other parameters will be included as an input, and some output parameters, not only compressive strength, maybe they study for water absorptions or other similar studies. Okay. So hope this is the code we have copied and pasted. Okay. Can you know till this you have completed? Hello, sir.
Yes, sir. Completed, sir.
Completed. Okay. So am I going very slow?
Yes, sir. It's correct. It's perfectly fine, sir.
Okay, fine, right. Okay. So again, next you have to click this code option and again go to the Word file. So next is explore the dataset. For exploring dataset, just copy the next step code. Just copy till this. And just paste here. Just click this run symbol. So you can get certain information here. So the purpose of adding this code is need to check all the column names, size, right? How many number of the basic statistics. What's the mean, standard deviations, average, maximum, right? Just a basic. This is also a part of uh, the data only, but anything is missing, any issues, for example, if something is missing, like some values missing means you will be able to get those details here. Okay, these are all till step 2. Now we are moving to the third step. Third is exploring the data clearly, like the column names, data size, missing values, statistics. Then fourth is features, target, and data split. You need to know what is input features, what is target variable, like input and output. Players, it is not kg per meter cube, it is in percentage. Okay. Now you need to understand one thing very important. We have 50 datas. This 50 data should undergo training. Okay, training and testing. You can see in the left hand, 80% is for training and 20% is for testing. Why this training and testing is doing is we are going to do a prediction based study. When you do a prediction studies, the prediction we need to test, right, whether it is perfectly predicting or not. Recently, I have attended one research meeting. There, a research students done around 1,200 samples, 1,200 concrete cubes in lab for around 3 years. Not 3 years, around 2 years. Now you need to understand. Do you think that much number of samples were required, and we know how much of natural resources were being wasted for doing that type of test? Limited number of tests, and then we can do the prediction studies. That is the main objective. You do 50 tests or maybe 100 studies. With that 100, you can predict remaining 900 or remaining 1100. Right? That's the main objective of these similar studies, because prediction is very important. And using these machine learning models, you can predict 95%, 99%, 98%. 98% is prediction, because most of our civil engineering based research, we always go for some factor of safety, right? So when 98%, 99% is predicted properly, we have a factor of safety. We don't have any problems in future. So okay. So now we can see here 80, 20 percentage. 80 is considered 80 percentage is considered for training, but some researchers they take 70, 20 also. 70, 30. 70 for train and 30 for testing. We are having 50 samples, so 40 samples for training and 10 samples for testing. Okay. So we go to this code, step 4. Just copy this. The step 4 one, just copy this. Again, paste. So here it is clearly said fly ash, cement, M-sand, seashell, right? That is considered as X and Y data sets, like compressive strength, that is the output. So input, target. So total number 50, and how many columns were 4, and here it is 1, right? So I think till step 4, how many of you completed? Everyone completed, sir? In machine learning, the data is very, very important. So why we are sharing this detail clearly here?
Completed, sir.
Completed, okay.
Yes, sir.
Okay. So students should understand, whenever you do any experimental studies, your data is very important, the results. Don't manipulate, or for example, you do for M20 and M30, and don't add in between values as M25, right? So try to add the real data to get the good perfect results, the predicted results. So till now we have completed till step 4, and the step 5 is we are, as I said, the splitting data, right? 80 percentage 20 or 70 30. So for this samples, I'm selecting around 80 and 80 percentage and 20%. So for this, there's a separate code you need to copy. Click code, paste, again run.
Hello, sir. Is it audible, sir?
To get the green tick from your end.
1 second, sir. Let me check.
Splitting like training 80 percentage and 20 testing,
Sir, up to
because
fifth step, sir. You're asking?
yeah.
Yeah, 1 second,
So
sir.
yeah, see here, as we are taking 80 20, so 40 percentage 10%. In case, see, I'm just giving this code and all. In later, maybe after this session, when you have free time, you can do these editings. This point 2, maybe you can change to point 3, so that it take
Sir, yes,
uh,
sir. Completed, sir.
completed, right? Okay.
Yes, sir.
Can you know other students also completed, sir?
Yes, sir. Yes, sir.
Okay. Now the next step. So next step is the core field. Now here we are going to build and train the XGBoost model, right? There are so many machine learning models. You just search, for example, in ChatGPT or any other tools, list out some 30 machine learning models normally used for predicting the compressive strength. It will provide you 20, 30 machine learning model. But our major objective is to find the best model to predict 98, 99. There are models will predict 70 percentage. Do you think predicting 70 percentage result is fine? Obviously no. If you are predicting something, it should be at least more than 0. Like 95 out of 1, which means 95%. Now you may think, sir, this why I am sharing all this code is sometimes you just copy this code. You just need to change for XGBoost. I just tell you, for example, I'm just giving a simple text like list 10 machine learning models like XGBoost to predict compressive strength of concrete means. Mostly it will give you a list, for example. Okay. Cat boost, gradient boost, neural networks, then SVR. These are all different machine learning models. Now you need to try which is the best. Why I'm sharing this code? The main purpose is you just copy this code, maybe somewhere from here. You just copy this code. Maybe you can ask the AI tool similar code. convert to mm, maybe this regression. Okay, Google Colab. So the code which I am having is for XGBoost machine learning model. Okay, but if I need a code for support vector regression machine learning model means you don't know to write line by line. You just give a sample similar code to any AI tools. It will convert all those details and it will provide you. Okay, because for each and every data, the model, for example, for each and every, because this is a sample, whatever I'm sharing is a sample. When you take your data and you do similar studies, sometimes for XGBoost it may get good results, but sometimes for XGBoost it can predict only 70%. It may not be useful. So you need to understand one thing very clearly. It's a trial and error, but you will be not doing mostly more than 10 or 15. In the 10 or 15 itself, you will find the best two or three. But before that, here you can, I just said right, for compressive strength, which are all the best top 10. So these are all mostly light BGM, cat boost, gradient boosting, random forest. If you go through maybe some journals, also you can find these machine learning models only mostly will be available. So now we need to copy this step 6 till steps 5 we have done, and step 6 copy this. Sometimes you are not comfortable in going to this Gemini. There is an option here itself. You just copy this code and ask Gemini to change, it will change. You just copy and paste here, or directly you just give a prompt here, similar thing I need to change for so and so, it will change. And just for example, I'm just giving. Because sometimes it will change the entire thing. So maybe I'm just stopping here. But in Gemini, it is possible directly. I think there's a changes. Okay. See here, it is changed gradient boosting, right? See, when I have stopped in between, so it has changed. So I'm just copying it once again. So copy the XGBoost code and just run. Now here you can find XGBoost model trained successfully. So this machine learning work with the training, lot of iterations, lot of things works behind. Okay. I'm going to share a presentations here to know a little bit of basics. See, build and train. This is the step 6 which we have did now. In the code you can find these values: n estimators, learning rate, maximum depth, subsamples, then reg alpha. So you need to understand what is the purpose of all these. XGBoost, I'll show you a small sample image. See, this is like a tree. It do a lot of iterations. It predict, and sometimes if it is not predict, again it's change. Go next, next, next. How we can predict? It automatically do lot of trial and error to make more than 95% predictions. Trial and error. Okay, it's like kind of tree, like first attempt, second attempt, third attempt. At one time of attempt, you can see here, tree 130, error keeps shrinking. Lot of errors are there. So when it is done, then finally the error is getting reduced at 130. So you can find Here the values will be n estimator is given at 130. So the backend, how these values are calculated, if you are not knowing also, don't worry. You can get help from Claude. Nowadays, many researchers prefer Claude. Claude is another tool. You just tell XGBoost, I need to know the best parameters to get more than 95 percentage of prediction results. So it will do a run with your data and it will say for n estimator you provide 125, 130, 145. Learning rate you provide 0. This. Maximum depth you give this. Subsample. Then if you run again, see here, now whatever I have given you just pasted here, right? Whatever I have given you have pasted. Some researchers, how they train the student is, you check 132, 131, 132, you just change one by one and see which is the best. But it will take lot of time. Okay. So don't spend that much of time. Copy this and get help from the AI tools. You upload your data, and for XGBoost, I'm just tuning the parameters. You suggest me the optimum parameters to get better results. So it will run the iterations and it will provide you all these values. Just enter it. Okay. If you are manually changing because 0.245, 0.250, it is a small because each parameters when you change, your entire results get changed. Okay. If the prediction is getting increased, it is fine, better. But if it is getting reduced, then again you, because not single parameters, there are around 6 to 8 parameters as there. So each and every parameters when you change again and again, it will be difficult. So better, I suggest you these entire things to the any AI tool, so it will provide you the optimum values. Just enter it and try it. Some researchers, they give all these details in their research article. Okay, when they, for example, think a research article, they did a similar study with around 54 datas, and they say an estimator they have given 134, 135, which means you can make a guess that maybe plus or minus 5 values, maybe for your data also it can be better. Okay, but the similar for input variables and output, because each and every data we cannot exactly say for your data you get a similar results, because I done collaborated with multiple researchers for different datas, but for different datas I get different n estimator, different learning rate. Like we cannot get the same similar. Okay, so we call this as a hyper parameters. So hope this code is copied and you have copied and pasted. And the next code is generate prediction on training and testing. So this we have to paste. I'm just copying the next step, which is step 7. So hopefully you could have also copy this 7 and just paste it. Now we can see here prediction generated, actual versus predicted test results. So what is the actual strength? 18.317. But what is the predicted one? 18.46. 17 for 17.24, 18.8, 18.6. So you can see the error in like maybe 1.6, right? It's not that huge. If you see these results 18.9, 18.2, 18.2, right? How this prediction and the results were closely related. Okay, this prediction and results is closely related. The most important thing is, okay, yeah, why I am getting this perfect prediction result is based on this hyper parameters. So you have enough time, you just change one by one and check to get the best predicted. If you don't have time, just upload your data and get the best one and you can do it. Okay. So till this everyone done? Can you not till this?
Say they completed. Sir.
completed. Okay.
Yes, sir.
Okay. So first, so I think step 6, 7. I think around 7 we have completed. Now we'll just learn about little bit about this XGBoost. Okay. A person named Ravi scored around 40 marks in his first math exam. His teacher looked at his mistake and gave him a targeted practice. Okay. In second test, he scored around 60 marks. The teacher again looked at the new mistakes and gave more practice. When he making more practice again and again. In the third test, he scored 75 marks. The teacher is practicing by giving multiple again, maybe 130 times. Maybe the Ravi gets scored around 97 marks. The background of this XGBoost works. Every model has a different way of making the best outcome. But XGBoost, the main purpose is it give a lot of practice again and again and bring the best. So XGBoost builds many small decision trees one after another, and each new trees fix the mistakes of the previous trees so that the final answer combined results of all three will be the best. So 97 marks means the assume as 97% of prediction result is getting better. Okay. The full form of XGBoost is extreme, extremely fast and accurate. Then gradient use mathematics to find the mistakes. Boost is each round it's boost, it improves the previous results. Because initially Ravi score is 40, then 60, then 75, 97. It is increasing, right? These small errors has been reduced and finally it is increasing. So this is the scheme of like each tree and each errors, how it is getting sorted out and finally going to get the best results. So for example, round one, the guess is 30 years is a real age for a person, but his real age is 45. We will assume, for example, maybe you think maybe me or Professor Vijay, we are making a guess 30 years, right? But his real age may be 45. What is the mistake? The error is 15 years, right? But second wrong, we are adding again 15 and we are making a guess and we are making a real age as 45, right? So similarly, 130 times the n estimator means it is that much round of studies were done, iterations were done to reduce the error and get the perfect predictions. Similarly, for n estimator, there's a how that works and learning rate, maximum depth. For example, learning rate is how big each correction step is. Maximum depth, the depth is how many questions each tree can ask. Like because again and again, when you do trial and errors only, it can be better. Then subsample, there is a value 0.62 means each tree has 62% of data randomly pick and train it to get a better results. And this alpha is something like punishments were given to make the perfect models. Okay. So this is the sample schematic image of uh, this XGBoost, how these runs and try to get the better results. Now we need to know for prediction, there's a content called performance matrix. We say how we can say it is 97% or 98% is getting predicted. So there are four major contents we to measure. First is R square. You can see the left hand R square. How much variations the model explain? Normally we don't take it as 100%. We take it as 1. Okay, in 1 means 100. So for 1, how much? You can see the training is 0.99 and testing is 0.97. The next is MAE. average absolute error, you can see the error is hardly 0.02 MPa is Newton per mm square. Okay, the errors. That RMSE is root mean square. The errors 0.03, 0.1, and mean square error is derived from the earlier one. So the results which we got is R square is equal to 0.99 for training, and for testing 0.97, which is both are more than 0.95, which is above the threshold, which means the model which we choose is an excellent model, right? So now again you go to the next step, step 8, copy the performance metrics code, just copy, just run. Copy the step 8 and you can run. So everyone just copied and pasted this and you got the results. Now after you pasted this, here you can find these 4 results: R square, RMSE, MAE, MSE. The interpretation guide is R square, which is closer to 1, which means the better, right? RMSE, if it is lower means better. MAE lower is also lower is better normally. So till this everyone completed. Sir, after students has
It's a
completed the
complete
step. Okay,
step
complete.
eight. Yes, yes.
Okay. So just I will discuss about the R square. R square is the percentage of the pattern your model has understand. Okay, you just given a data. We need to understand the pattern because some patterns will be very linear. You add percentage of seashell, the results will be good. Sometimes in some ratios it will be not a linear results. Suddenly it may results. Recently I worked for one researcher. That when we are adding cement, the strength is increased. At one point of time, it is getting reduced. I think even here also similar studies. We can see the results, which means you are not supposed to use that percentage in real time. Okay, that certain ratios. So R square means 0.97. For example, the model understand nearly 97 percentage. If it is zero point 0.5 means 50 percentage. One means 100 percentage understand, but preferably not to have one. At least 0.99 is better. Sometimes in 100, many experts suggest that maybe it may not train properly. Sometimes there may be an error. So 98, 99 is always better, right? So R square 0 means the model has not trained properly. And the analog, how it became is like how I said some teacher kind of story, right? Similarly, how it is getting boosting and finally how it is getting smarter. So that's how the R square is taken. You can just give a read when you have time. So R square 1 means the perfect exact, then 97 means excellent, 95 is very good, 90 is good. But to go for a publication level, it should be more than 95. I prefer not to have perfectly one, but 98, 9 will be always better, right? So for this results, 9 is for training and 7 for testing. And next you can see another one is called LOOCV, which is Loo cross validation. Now this is an R square value we are getting, but we have to validate whether the results which we got from the performance metrics is correct or not. To check that, there are majorly two cross validation most of the researchers use. One is k-fold and another one is loop. It is like lose one after one, something like that. The name will be a leave one out test. Okay, that's how the test will be. In that cross validation is we are just checking whether the R square which we get from the earlier study is correct or not. When you do your cross validation also, it must be greater than 95 percentage or 0.95. Okay, so you need to understand about this MAE. For example, a person named Ravi, mother sent him to buy 19.8 kg of rice. He comes back with 19.4 kg and he is having how much shortage? 0.4 kg, right? So the error is zero point 0.4. You think the similar perspective for compressive strength. The predicted is 40, 19.40, but actual is 19.80. So the what is an error? Error is 0.40 MPa, which is very too low, right? Very less, right? So MAE mean absolute error. Okay, that's how the name has been derived. A sample for real time. What Ravi bought 19.4, 19.10, 17 point, but what should he buy is 19.8. So the error, all error were taken without any sign and divided by the total number of sample. For example, we have 50 samples, right? So, like what are all the errors divided by 50? So we get some zero point 0 some MPa, which means if it is less, it is better. If the error is more than 1, 2, 3 MPa, then that is not good. Similarly, mean squared error. So here the values will be somewhere around 0.16. If it is 0.10 in that range, which means the error is very less. If it is more than 1, the error is little bit big. If it is more than 2, it's a huge mistakes, right? So it's kind of a strict teacher gives punishments for being late. 5 minutes late, 5 lines to write. 10 minutes late, 40 lines to write. 30 minutes late, 900 lines, something like that. Okay. So it's a if the value is very less small, then you get a better results. That's all. So the big problem in this MSE, there's a problem because mean squared error. But do you think we will square our compressive strength values? Meter MPa like Newton per mm square into square? No. Nobody measured the compressive strength in MPa square. So it is an unreadable content, but for that purpose only we are going for the RMSE, root mean square error instant. Okay. Root mean squared error. Here you get a results of 0.805, which means when you take a root, you get 0.284 MPa and you can convert that to a readable unit again. So when you do a performance matrix, these values should be less and the R square value should be higher, the maximum more than 0.95, right? Because we are going to predict, but the prediction should be the best, right? So for that we are just checking all these the metrics. Then this is a simple golden rules. MAE and RMSE lower is always better. R square is higher is better. Maximum is 1, but 0.99 is better always. RMSE will be always greater than MAE. Okay, mean then always check for train separately, test separately, and in both it should be greater than 0.95 for a publication level quality. Okay, till this everyone understand? Till this? So hope you understand. And the next step is you can copy the next maybe step 9. Just click code here, just paste, just run this code. and you get a graph like this here.
So they're completed, sir.
Completed, huh? Okay, okay,
Completed up to the graph.
okay. Actually, here it will be 0.97 because I have a screenshot where it shows 0.97, but there it is 9. I don't know what is the reason. I just need to check with the datas. Okay, as of now, so this is a graph we normally call as scatter plot. Scatter, scatter plot. So in this scatter plot, you have blue dotted lines in the center. We call that as a fit line. And then you will have red circle belongs to training, green circle belongs to test, which means you will have 40 training and 10 testing. 10 green circle, 40 red circles. Okay. Now you need to understand this graph normally. Normally the graphs comes under this three category: underfit, optimal, overfit. Why I said exactly one is not good. The R square value exactly one is not good. Why? Because sometimes it will be overfit. The values will be exactly the same. Maybe there may be an internal error. The testing may not be properly done. Only training could have done. So there may be an error. So overfit is not suggestible. Underfit also not suggestible. The values will not be closely related to the optimum predicted values. But the optimum one is you have a perfect fit line and the values will be closely nearby this perfect line. So that is always the suggestible one. So you can see R square, which is 0.999, which means it is perfect. If it is 0.66 means it is not fail because uh, maybe overfitting or underfitting, there may be a lot of errors. So this is the results. So can I know everyone you got 0.97 or 93 per test? Sir, sir, anyone?
So 1 second, sir.
Okay, you got this test R square as 0.97 or 93?
Sir, some of them getting 0.93, some of them getting 99, I think.
97, huh?
90, most of them getting 9.9309.
Okay, okay. I'm also get 93, but actually we will get 97. Maybe I don't know in the code any error, like what I shared, maybe any errors or I'll check the later files. But for both we must get greater than 95, 0.95. Okay, we have to get 0.95 to get a better results. Okay, there are many validation. Maybe this step 10 I will just skip. Okay, this is also simple. You can just I will share the slides later. You can explore this fivefold. I just go to this uh, leave one out cross validation. Both are cross validation. When you go for a research publication, you don't want to do both. You can do any one cross validation and say whether the validation is perfect or not. So I take leave one out cross validations because many articles, reputed journals like Nature, certain quality journals, you will find this leave one out cross validations. So in this cross validations, normally you can see 0.97. The value is like our L over C R square is 0.97. So you just go to the code, just skip the step 10 and go to the step 11 and copy this code and you can paste here. So here you can find few values. it is 0.97. Actually, it will be 97. I don't know what is the reason behind. I will just need to explore it. In case you find an error, you can just get help from some AI source to sort it out those errors. And this cross validation also 0.1, 0.07. This is very less, comparatively less. Then the model which you predicted, we have chosen XGBoost, right? If it is lesser and it is greater than 0.95, then it is best. Okay, the predictions will be best. I will show you some of the results from my own article. Then the next step is you need to click this code again. Copy. The next step is shop feature importance analysis. Copy this code and paste. It's okay. Everyone getting the same error?
Yes, sir. Yes, sir.
Okay. Click explain error. So I think some error related to split. Maybe here the content may be related to accept and run. When you click explain error, it goes to this Gemini and it will explore our code and try to sort it out this error. See, if there's an error related to categorical split means we have splitted 80-20, right? Sometimes here inside it may be for 70-30. Actually, I made a mistake in between. I just asked the AI tool to change to gradient boosting, right? So it did a lot of changes in between, I think. Because I just give a, yes, you can see here somewhere it is showing, right? See, gradient boosting. Actually, we are doing for XGBoost, but see the gradient boosting is added because just for teaching you, I just uh, in case if you like to add for gradient boosting, you have to add, right? I just gradient boosting is another machine learning model. I think now I have received a graph. Maybe I will copy this code and I share to you, if possible. Professor, you can share to them this code
Yes.
which I shared in the chat box. See, when students, when you're practicing on your own in future, just copy this code and paste, you will get the exact results. But I during this session I just made, if you have to change to another model, I just clicked and send, similarly do for gradient boosting, right? So in between, uh, the gradient boosting model is also added. That is the reason maybe you get certain errors. Errors also, don't worry, this Gemini will help you to sort it out those errors. So can you know everyone get this both graphs?
So one second, sir. I'm
Yeah, okay,
checking.
okay, okay. So when it's completed, let me know, sir.
Sir, it's showing the same error. I think students are saying that they are getting the same error.
When they copy this code.
Yes, sir. The chat box which you have shared.
Okay, okay, sir. Okay, okay. I need to know one thing. Ask the students to check whether this gradient boosting thing is available in their first. Okay, sorry. See, we are going to do only XGBoost, but you can see here how this gradient boosting is came is. I just for changing this to another model, I just I use this Gemini and I have added, right. So it made a changes. That is the reason maybe the students may be getting the error. So once again, I am just deleting this once again. I'm just copying and pasting the old one. There is an option, not this. Okay. Just copy this. It will show some error. Click explain error. Because this code will get confused whether to work for XGBoost or the another one, gradient boosting, another machine learning model. So just see what I'm doing. Just click explain the error and click accept. So anyone got that graph? Finally, you get like this: accept and run. Click accept and run. So can you know everyone got this?
Yes, sir. Getting.
Okay. Everyone, can you please check?
So they're getting the graph.
Okay. See, the the shop feature important analysis, which means sharply additive explanation. That is a term. Here you need to understand one thing very clearly is you have two graphs. Everyone got this two graph, right? We call the first graph as B swarm plot dot by dot. Okay. And next graph is we call as a feature importance. Both has a similar meaning. What is the meaning is clearly you need to know. Because of C shell has the higher importance. Because of C shell only, the compressive strength parameter is getting changed a lot. Next is based on the M sand. Third is fly ash, and fourth is cement. See, there are four students worked on a group project together, like seashell, M sand, fly ash, and cement. The group scored 19.8 marks out of 20. Now, the teacher has to give a mark for each and everyone who have contributed. Sometimes seashell could have performed better, everybody performance. So, fairly mathematically, they have to separate the marks out of the 19.8 to all members, maybe seashell, imsan, fly ash, and sim. The shop tells you how much each ingredient pushed the prediction up or down. Okay, because your compressed strength is obviously getting upper. You need to know one few details here is the color. You can see pink color and blue color, right? See the top one, mostly pink, the top till the blue. Pink means high amount of that ingredients were influenced. Blue means low amount of that ingredients were influenced. Then positions, right side, left side, from zero to far. So this tells these, but in a very simplified manner, if you like to know how, you can see this once again. C shell has the major importance here to determine the compressive strength of the C shell aggregate concrete. And some bars will be longer, some bars will be less, and the dots you can see from zero in one side maybe a little bit longer, and other side it will be lesser, right? And pink dot means high amount of that ingredient that mix, and blue dot means low amount, and there's a purple dot means something around the medium amount. More seashell obviously stronger concrete, less seashell weaker concrete. Seashell controls the strength the most, okay, not other parameters. Because seashell bars is 6 times longer than M sand. Seashell is 6 times more important than M sand, something like that, right? And you can see values where 0.44 MPa, right? See here, 0.44 plus 0.7, which means 0.44 means the average seashell were pushed prediction by 0.44 up for each levels. Similarly for M sand, right? M sand has a very smaller influence. In each ratios maybe 0.07 MPa only, it is getting increased. That's the changes it can do. And here you can find, for example, mix one. You just take only one mix, seashell, M sand, fly ash, cement. The predictions were pushed to plus 20 MPa and 0.15 MPa. And when you see finally, 18.31 is not the correct one. The final prediction is 19.8, which means 1.49 MPa, there is a kind of an error, right? So these are all, if it is very less, it is fine. But if it is more, it is not good. The prediction one is. And okay, here you need to understand one more thing. Most of the research article, I will show you a sample related to this. So this is one research article recently did with a researcher from Coimbatore. So we did only XGBoost, right? Here you can find gradient boosting, XGBoost, CAD boost, SVR, right? This 10 machine learning studies were done, and we found the gradient boosting is better. And this is the machine learning work plan. First, the data processing, cleaning the data, splitting the data, C80-20, training, testing. Then 13 machine learning models were screened. then model getting constructed, then parameters tuning, then the cross validations we have done. Then we have executing the initial evaluation, that how it is getting predicted, and all the model values like R square, MSE, MAE, then final validations like cross validation, LOCB, SHOP, and the final one is graphical user interface. This is the basic machine learning methodology. So this is his studies, the experimental studies. So this is a scatter plot for the top three. One is GB gradient boosting and XGBoost and cat boost. Okay, this is not related. Okay, this is the cross validation. See why this cross validation is very important is, you can see this graph. Actual is black color, and the green one is gradient boosting, which is 0.9928. You can see S1 is sample 1, S11 is sample 11, 21, because here the sample is many numbers, nearly 360 samples. You can see the line. In some places only you can find the results were not that close, but most of the place you can see the results, the predicted result is very close. The predicted result is very close. Don't worry about these kind of new graphs. You just upload this graph to AI tool that you need to create a similar graph in because I too take this image similar graph ideas from one research article and I upload it to an AI tool that I also need to have a similar graph to plot in Google Colab. So it will give you the code. Just you run the code, you will get these results. You will get this graph. But how you write the inference is very important. Obviously, if it is 0.9928, the remaining percentage will be some error. You can see some. If you zoom and see, in some places you will find some errors. So this is the shop. So here temperature, yeah, concrete is exposed to temperature. Based on the temperature only, the strength is getting influenced. If you are undergoing temperature, here even exposed to temperature 91%, right? Here it is in percentage. So next graph we are going to learn about this partial dependence plot. So now go to this code, copy the partial dependence plot for all the 4 features. Just copy the code. And just click code and paste. If it's not running, obviously follow the same earlier one. So here you can get the graph immediately. Everyone get the graph?
So they get
They are getting okay. So everyone is, you are getting the graph, right? Now for seashell, if you see the graph, it's going towards up, right? Positive, which means more seashell you are adding, higher the strength, right? Because if you see the data sets, compressive strength starting from 17.5 till 13.3, it is getting increased when we are adding more seashells. Then in M sand, you can see in between you will find a negative, which means the mixture M sand at certain ratio, it reduces the strength. Then fly ash, you can see the inverted U, and cement you can find a short V curve. So you can see one by one. I think this results you could have got. If a mother is making a recipe, the final taste depends on salt, chili, sugar, and oil. She wants to know, if I change a salt amount to certain percentage, how does this taste change? She tried with 10 different salts and record the each taste shot. Like similarly, in each, because we are changing the percentage for cement, we are changing the percentage for fly ash, we are changing the percentage for another one element, and we need to find that at which percentage or which time you are getting the better strength and which time it is getting reduced, right? And this PDP answers this question, which is if I change one ingredient across the full range, what changes, what the predicted changes are happening. Okay, that's about the partial difference graphs. So this is related to sharp. Okay, this is for seashell. Obviously, it is going up, so not an issue. See here, at seashell at 10, the strength is 17. Seashell at 30%, it is 18, and at 50%, it is 19.3. Okay, this is a not big thing. Then M sand, see 20 to 40 percentage. Here you need to understand. At 20, it is 18.4. It is increased. But when you go for 40 percentage, it is getting again decreased, 18.1. So M sand you fix 18.4. You can optimize it. Don't go more than like 20 percentage, right? The next is yeah, it's negative. Okay, this is the same. Then fly ash. Fly ash you can see in 30, in 20 percentage if you're adding the fly ash, the strength is around 18.25. But at 30, again it is getting increased. But at 40, again it is getting reduced to 18.23. Right. So these are all you need to know the optimum one should you finally use for your studies. Then similarly, I think this is for fly ash and this is for cement. Cement also similar. So 10 percentage it is increased, 14 percentage is reduced, 20 percentage again slightly there is a small dip, right? So these all you will be learning, and you need to know about this. Uh, this is a final graphical user interface. Like when you add this random percentage value, you get the predicted compressive strength. To do this, very simple. After you get the entire code, you can download this code. Mm, When you click download the Python, you just download the Python code, import to some Gemini or Claude, any other tool. Just as the tool, you need to convert this. You have to use Visual Studio Code. You have to use this Visual Studio Code, and you have to give simple prompts like. So this is one recent one of the study. I'll just play and I will show you. Don't know whether it will work or not. Okay, maybe that's not a part of this today's content. Actually, seashell training. Okay. So this code, don't think I'm a software engineer. I just created this entire code using AI tools only. After downloading this, I just asked to the tool that I need to create a graphical user interface like this. Okay. So when you just copy this code to this Visual Basic Studio, it's a Python code, and if you run, you will get a graphical user interface. You can upload this code in your GitHub repository, and maybe in future it can be created as a web application or kind of. So the main objective of this prediction study is you don't want to do 500,000 number of samples for doing your experimental study. Do a very limited studies and do the better prediction. That is the main objective. So these are all the summary which we get in the earlier model metrics and all. Finally, when you do this 12, 13 steps, you'll able to get the predictions. So now here I've given a sample data and I just did right. Now the major task is you could have already done certain studies for your lab. Maybe you have certain less number of study, means for example you have only 20 samples or 30 samples. Try to spend a little bit of time and uh, get some more samples, maybe 50 samples, 100, like maybe as a team you can work together. You can uh, hopefully your supervisors will help you, and you try to create more number of data, and with that data try to do machine learning task. You will be able to publish your research article easily. First thing, when you publish you get a broader opportunities. When you go for an interview in maybe final year or other years, they'll ask you to tell about your project, so you can tell them that I did a task in machine learning with these data. And later on you can learn these code. Obviously in our 12th class we could have studied this basic programming, right? You can learn this code line by line. Okay, it is easy only, but you need to spend a little bit of time. But most important thing here is uh, which parameters influence the most, when it how why it is increasing, why it is reducing. For example, at 20 percentage it may not increase, at 30 it is increased, then again 40 it may reduce. But why it happens? So that scientific reasons you have to provide technical. For that, these studies should be for example 20, 30, 40, right? This 20, 30, 40 maybe in scaling and material characterization based study should be done. 20, 30 and 40. So how the concrete behavior is, to we call that as a physics informed. The background of the physics behind this material studies, why the strength is increased at one point of time and why it is reduced. That scientific inference we have to provide. You can publish a good quality articles and it is very easy, and this also runs maybe 2-3 years. This will go very well. Maybe the next stage is again is a different. Nowadays many researchers started creating these kind of agents. So now I did this step by step, right? Now without giving step by step, I just copy the entire code and paste. Also it will run. It will run. But you can copy the entire code and ask to the AI tool, convert this similar code to gradient boosting and just paste. You will get the results for gradient boosting. Same code you ask the AI tool to convert to cat boost, it will convert and provide you. We can convert it. So you can play around with this tool. It's a very user-friendly tool. It will really helpful to get some quality publication. Do some initial most important thing is the data. Maybe you work with brick or mortar. You work with, if you're working with material. Sometimes you work with some softwares. I know some researchers here in Malaysia. They install ANSYS, Abacus, and certain softwares. They do some fire-related studies or a lot of studies, and they create data. And with the data, they do machine learning studies and predictions-based studies. So thank you all for your time, and I'd like to thank Professor for the opportunity. So any queries from any students, and you can let me know. I will share these presentations to the same email ID to maybe Professor Vijay and to Professor the head of the department, Professor Kumudha. Right. Okay.
Sir,
Yes, Professor. Yes.
so is it, yeah. Sir, one doubt is like how to generate those code you have generated, sir. Is it using a AI tool or we need to study something or?
Yeah. How I get the code is, there is I have
Uh,
attended a similar event like this. The researcher did for mechanical applications. He did for mechanical applications, but it's a different data. Then I get the help from AI tool. This is my data, and for this data, I need a code. So it give me a code for this model, and I'm just doing it. You can get the help from AI tool. See, our main objective is not the code creations. That is very easy. But main objective is how this can helpful for making the predictions. outcome. Application side, we have to focus very much, rather than, because these codes can be created easily through these AI tools.
And one more thing, sir. If I give more input as a variable, I will get more accurate data. Is it right, sir? Is it?
It can be, see, what you need to predict, that has to be as an input as well as outcome. For example, if you give like small parameters like water cement ratios, or thickness of seashell, any density or any other parameters of seashells, if you give more parameters, in each and every parameters, how that is getting influenced for compressed strength, we can know, sir.
Thank you, sir.
Yes, sir.
So I don't think they have any doubts. So
Okay.
thank you, sir. On behalf of the Department of
Thank
Civil
you, sir.
Engineering, I take this opportunity to express my thanks to you for delivering this lecture, and thank you for explaining the concept behind XGBoost regression and demonstrating how machine learning can be effectively applied to predict the compressive strength of the concrete. And this hands-on session will provide valuable practical exposure and help them to understand the complete flow from data analysis and model development to predict and interpret the results. And once again, I thank you, sir, for your valuable time and expertise.
Thank you, sir. Thank you.
Sir, actually, ma'am went to class. Actually, I'll little more.
Okay.
I'll inform.
Okay. Thank you, sir. Thank you, sir. Thank you, sir. Bye, sir.
Thank you so much, sir.
Thank you, sir. Thanks.